Hey, what's going on, guys? In this video we are going to see an example on reduction of order, and here this question is asking to find out the general solution and the second solution of this differential equation, and also they have given that y1 x is equal to x power negative 1. In this kind of problem what we do is we take the y2 x is equal to g of x, so we take a function of x and we multiply that one by y1 x, and that's going to be our y of x, y2x. So let's say y2x is equal to y of x, and I'm going to multiply this value with a function of x. So let's call that one u of x multiplied by this one, that's x power negative 1. Okay, this is the first step. Now what we have to do is we have to replace these values with this equation, but in order to do that we have to find out y prime, and also we need y double prime. Here we have y, we can replace this one, but we have to find y prime. If we find y prime, since this is a function of x and this also function of x, we have to do the product rule. So first one is going to be just before I do that I just write it as u x minus 1. Okay, or we can write it as just u over x. Okay, and it's better to keep u x minus 1 because in that way it's easy to find the derivative, u x minus 1. And if we find the derivative, first we take the derivative of this one and keep the other one as it is, and then we keep the other one as it is and take the derivative of this one. Derivative of this one is going to be minus 1 times x power minus 2. So let's keep the minus 1 in front, and x power minus 2, and this is going to be the first derivative. Now to do the second derivative, again it's going to be a product rule. For this one, this is going to be u double prime x power minus 1, then minus x power minus 2 u prime. Okay, this is for the first one. Now let's look at the second one. Second one is going to become plus 2 u x power minus 3, and then this is going to become minus u prime x power minus 2. Okay, now let's see what we can do from here. Let's see whether we can add something. We have u prime x power minus 2, u prime x power minus 2, so we can combine these two together, and that's going to give us u double prime x power minus 1, then u prime x minus 2, u prime x minus 2, that's going to become 2 u prime x power minus 2, and here we have 2u x power minus 3. Okay, now we can go ahead and plug it in this equation. That's going to give us x square, y double prime is this one, that's going to be u double prime x power minus 1 minus 2u prime x power minus 2 plus 2u x power minus 3 and 3xy prime, so plus 3x, and y prime is this one, so let's put that one right here. So this is going to be u prime x power minus 1 minus u x power minus 2, and after that we have y, that is this one, plus u x minus 1, that's going to be equal to 0. Now let's combine them together. So this is going to become u double prime x minus 2u prime, and then here we are going to have 2u x power minus 1, 2u x power minus 1. Okay, let's get rid of this, 2u x power minus 1, and after that we have this one, 3x, and x power minus 1 cancel, so we will get 3u prime, that's it, 3u prime, and this is going to become 3u, and it's negative 3u x power minus 1, and this is going to be just as it is, u x power minus 1. Now let's see whether we can add and subtract each other, and here you can see 2u x minus 1, 3u x minus 1, u x minus 1. So when we do the direct reduction of order, always these three terms will cancel. Whatever the u values, it will cancel each other. So you can see that 2, 1 is, and here we have minus 3, plus 3, minus 3, so that's going to add up to 0. and this one always happens in reduction of order. And let's look at the other terms. We have 2u negative 2u prime plus 3u prime, and that one is going to add up to 1u prime. So we will get u double prime x plus u prime. Okay, so that's what we get. That's equal to 0. Now we are going to reduce the order. In order to do that, we let w is equal to u prime, and we let w prime is equal to u double prime, and write this equation in terms of w and w prime and w. So that's going to become w prime x plus w is equal to 0, and from this one you can see this is separable. This w prime we can write it as dw over dx x, and plus w is equal to 0. Now we can separate and integrate because this is separable equation. Let's separate. So this is going to become dw x dw over dx x is equal to minus w. Okay, now if I bring this x to the other side, that's going to become, so let's continue here. So dx, this dx has to be on top in order to integrate, so we have to bring x to the other side and w to this side. So this is going to become 1 over w dw is equal to negative 1 over x dx. Now we can go ahead and do the integration. Let's integrate this one, and this one is going to give us ln of w, and in the other side we are going to have negative ln of x, and also we have to put a constant. Let's put it as c. Okay, now to get rid of this ln, we can take e power. So e power this one, e power this one, e power ln of w, that's going to be just w, and e power negative ln x plus constant, we can write it as e power minus ln of x. So when the power adds, it multiplies, so e power constant. And here negative, when we have negative we cannot do anything, so we have to move this negative to the power. So that's going to become w is equal to e power ln of x minus 1, and e power constant we can replace this one with c2. Okay, because the whole thing is going to be constant, so we put it as c2, and e power ln of x minus 1, that's going to be just x minus 1 times c2. Finally that will give us, I have to get rid of this, so let's get rid of this one. Okay, now let's continue. So this is going to become w is equal to c2 over x, and this is c2 over x, and that's it. Now we have done with w. Now we can replace this. Remember that we took w is equal to u prime is equal to w, so now we have to plug it back. So instead of w we have to put u prime or du by dx, that's equal to c2 by x, and now again we can separate and integrate. Now this is going to become du is equal to c2 by x dx. Now let's go ahead and do the integration, and if you integrate this one and this one, this is going to become just u, and this is going to become ln of x, c2 ln of x, because c2 is a constant, c2 ln of x, and also we have to put another constant, that's let's say that is c1. Okay, now we have written everything, and finally we know that y of x is equal to u power x minus 1, so u must be equal to y of x over x minus 1. Okay, so it's same as x, so like y of x over x minus 1 mean 1 over x, and that's going to be multiplied by y of x, so y of x times x is going to be equal to u. So we can replace this u with that one, so we can say y of x times x is equal to u. So we replace the u right here, and then this is going to remain the same, c2 ln of x plus c1. Now if I bring this x to the other side, that's going to become y of x is equal to c2 ln of x divided by x plus c1 divided by x. Okay, and now this is the general solution for this differential equation. This is our general solution for the differential equation. So that's first part. The second part is asking what is the second solution of the differential equation. Now the given solution is x power minus 1, that is this term. If you put c to 0 and you will get if you keep c1 as 1, you will get this one. So that is this one, right? And if you put c1 0 and if you put c2 as 1, that's going to give us the second solution. That is, let's write it with a different color. y2x is going to be equal to ln of x over x, ln of x over x, and this is going to be the second solution for this differential equation. I hope this helps. Thanks for watching.